Welcome to this explainer. I am absolutely pumped you're here. Today, I'm tossing on my math mentor hat, and we are going to dive deep into a true mental math masterclass. Seriously, we're going to completely transform how you look at numbers. If you've ever felt intimidated by large calculations, or, if you just want to sharpen your mind and basically become a human calculator, you're in exactly the right place. We're going to establish some core algorithmic patterns today that will drastically speed up your mental processing time. Okay, let's jump right in. So be totally honest with yourself right now. Could you calculate 86 times 84 in exactly 5 seconds? And no grabbing your phone. I know a vast majority of people would really struggle to find that answer under pressure. It looks messy, it looks complicated, and traditional math tells us we need a pen, some paper, and a whole lot of carrying over to solve it. But what if I told you that by the end of our time together today, you're going to solve this exact problem in your head effortlessly and literally faster than it takes to even open your calculator app? All right, here is our roadmap for the explainer. Number 1, ditching your calculator. Number 2, the split and sum method. Number 3, squaring numbers ending in 5. Number 4, the same prefix multiplication rule. And finally, number 5, becoming a human calculator. Section 1, ditching your calculator. We've all been completely conditioned to instinctively grab our phones the second a two-digit multiplication problem pops up, right? But honestly, relying on a calculator totally interrupts your brain's natural flow state. By utilizing simple, hidden algebraic patterns, we can achieve calculation speeds that are actually way faster than the time it takes to pull your phone out, unlock it, and awkwardly type the numbers in. The traditional multi-line school method is just time-consuming and frankly error-prone. You multiply the units, you carry the tens, multiply the tens, add a 0 for the next line, do the whole shebang again, and then add the columns. What we're doing today is ditching that completely for the one-line mental math method. We're going to recognize specific number parameters and apply these slick one-line formulas that just spit out the answer instantly. Section 2, the split and sum method. Okay, this is a brilliantly fast little algorithm designed specifically to multiply any two-digit number by 11. It's the absolute perfect foundational trick to get your brain used to spotting structural patterns instead of just brute forcing the arithmetic. Let's map this out step by step. Let's take the problem 43 times 11. Step 1. You take the number you're multiplying by 11, so 43 here, and you just split the digits apart. You picture the 4 on one side, the 3 on the other, and you leave a little gap right in the middle. Step 2, you simply add those two digits together. 4 plus 3 equals 7. Step 3, you drop that sum, the 7, right into that center gap. And boom, there's your answer, 473. It is literally that fast. But the why behind this algebraic pattern is just as crucial as the how. Let's geek out for a second. When you multiply 43 by 11 algebraically, you're really doing 43 times 10 plus 43 times 1, right? That's 430 plus 43. So the hundreds digit remains the 4, the units digit remains the 3, and that tens place is literally just the 4 and the 3 collapsing together. Once you grasp that underlying architecture, you will absolutely never do it the long way again. Now, the really important part is understanding the boundaries of these rules. Like, what happens when the numbers get a little bit bigger? How would you mentally tackle 68 times 11? If you try our split and sum method exactly as is, you split the 6 and the 8, right? But then you add 6 plus 8 and you get 14. Well, you can't exactly shove a two-digit number like 14 into a single center slot and say the answer is 6148. That obviously makes zero mathematical sense. Enter the carry rule. It's a completely elegant fix. You still add the two digits, so 6 plus 8 gives us 14. You take the final digit of that sum, which is the 4, and you place that in the center. Then you simply carry that leftover 1 over to the left and add it to your starting digit. So the 6 on the left gets a 1 added to it, instantly transforming it into a 7. Making our final perfectly calculated answer 748. Lightning fast, right? You are successfully doing multi-step algebra entirely in your working memory. And here's a crazy fun fact from our sources. This logic actually scales up to three-digit numbers. Let's say it's 352 times 11. You just bring down the 3 and the 2 on the outsides and do two separate center additions. 3 plus 5 is 8. 5 plus 2 is 7, giving you 3,872. You are officially faster than a calculator. Section 3, squaring numbers ending in 5. All right, let's pivot and tackle squaring two-digit numbers that end in a 5. Think of stuff like 35 squared, 65 squared, or 85 squared. Normally, these are huge headaches to do mentally, but they actually share this beautiful hidden mathematical symmetry that we can totally exploit. We use what's called the next number up multiplier.
To square any number ending in 5, you just take the first digit and multiply it by the very next consecutive number up. Then you simply slap a 25 on the end. So why does this actually work? Well, any number ending in 5 can basically be written out as 10n plus 5. If you square that whole expression, the algebra always simplifies to 100 times n plus 1 plus 25. That n times n plus 1 part, that's exactly our first digit times the next consecutive number trick. And the plus 25 at the end is exactly why the final answer always ends in 25.
Let's actually map this out because it is super satisfying to see in practice. Take 35 times 35. The first digit is 3. The next number up is 4. 3 times 4 is 12. Attach 25, bam, 1225. Easy. Let's do a harder one. 75 times 75. First digit is 7. The next number up is 8. 7 times 8 is 56. Attach 25, 5625. You are literally computing complex squares in a fraction of a second.
Okay, I'm putting you on the spot. It's your turn. Apply this exact rule right now to calculate 95 times 95. Think about it. The first digit is 9. What's the next consecutive number? It's 10. Multiply 9 by 10, you get 90. Attach 25 to the end, and your answer is 9025. Fantastic! You're actively recognizing math patterns that honestly, 95% of people completely miss.
Section 4, Same Prefix Multiplication Rule.
This right here is the absolute crown jewel of our explainer today. It's a slightly more advanced trick, but it is unbelievably powerful because it builds directly on that next number up logic we just went over, but it lets us multiply totally different numbers together. To pull this off, you kind of have to play detective and look for two strict mathematical conditions. First, the prefix, meaning the first digits of both numbers, must be exactly the same. Second, the ending digits of those two numbers have to add up to exactly 10. If you spot a problem out in the wild that meets these two criteria, you can literally solve it in a single line. Let's break down the logic with a real example. 44 times 46. First, let's check our conditions. First digits are both 4. Check. Last digits are 4 and 6, which sum perfectly to 10. Check. Okay, step 1. Multiply the matching prefix, which is 4, by the next number up, which is 5. 4 times 5 is 20. That is the very first half of your answer. Step 2. Multiply the ending digits together. 4 times 6 is 24. That's your second half. Step 3. Just combine them. Put 20 and 24 side by side, and you get 2024. Let's run through one more just to really cement this new neural pathway. 67 times 63. The prefixes match, they're both 6. The endings, 7 and 3, sum to exactly 10. So we are cleared for launch. Take the 6 multiplied by the next number up, which is 7. 6 times 7 is 42. Next, take those ending digits. 7 times 3, which is 21. Put them right next to each other, and our final answer is 4221. Which brings us all the way back full circle to that impossible-looking hook from the very beginning of this explainer. 86 times 84. You know the secret now. The prefixes match. They are both 8. The endings sum to 10, since we have a 6 and a 4. So, take 8 times the next number up, 9, which gives us 72. Then take the endings, 6 times 4, giving us 24. Push them together, and you have 7,224. You just solved a massive, complex problem in seconds, entirely in your head. Absolutely incredible.
Section 5. Becoming a human calculator.
By utilizing the split and sum method, by understanding the real algebraic pattern behind squaring numbers ending in 5, and by mastering the same prefix rule, you have fundamentally upgraded your mental mathematical toolkit. You aren't just memorizing, you're finally seeing the hidden architecture of the numbers themselves. Oh, actually, before we wrap up, our sources dropped this absolutely brilliant bonus tip for the real world, and I have to share it. This is perfect for when you're out at a restaurant trying to calculate a tip. X% of Y is mathematically identical to Y% of X. Seriously. So if you're sitting there struggling to calculate an 18% tip on a $50 bill in your head, just flip it. Calculate 50% of 18 instead. Half of 18 is 9. Boom. The tip is $9. It is a stunningly simple trick that saves you so much mental friction. So my final question for you today is this. Are you fully ready to ditch the calculator? Let's do one final real-time test of your brand new human calculator skills. What is 89 times 81? Think about the steps. 8 times 9 is 72, 9 times 1 is 9, but wait, remember we need 2 digits for the back half, so it's 09. Combine them and you get 7209. Keep practicing these patterns, start looking for them in your everyday life, and just watch as your mental processing speeds absolutely soar. Thank you so much for joining me in this explainer today, and hey, happy calculating.